We are going to learn about remainder and factor theorem. Okay. Before that, we should remember what is a polynomial. What is a polynomial? What is a polynomial? Polynomial is an algebraic expression having two or more terms. It is an algebraic expression. For example, consider one polynomial. The name of that polynomial is fx. Okay. Consider one polynomial 2x square minus 3x plus 5. It is a polynomial having three terms 1, 2 and 3. Do you remember what is the power of that polynomial? Here power is 2. Here power of the polynomial is 2. These things you have already learned. Okay. So fx is 2x square minus 3x plus 5. And the value of this polynomial depends on the value of x. When x varies, the value of the polynomial is also varies. Okay. Suppose value of x is 3. If x is 3, you can find the value of fx. Fx means instead of x, we can substitute 3 because we are considering x as 3. Therefore, fx can be written as f of 3. We can find the value of f of 3. Just to substitute 3 instead of x, you can see here x is 3. F of 3 is equal to 2 into 3 square minus 3 into 3 plus 5. Right? Now simplify this. You will get 3 square is 9. 9 into 2, 18 minus 3 into 3, 9 plus 5. When you simplify this, you will get answer 14. Apply BODMAS rule for simplification. First addition, then subtraction. 18 plus 5 minus 9, which is 14. Okay. Suppose the value of x is another one we can take. Suppose x is negative 1. Consider x as negative 1. Then we can find what is f of negative 1. When x is negative 1, find the value of fx. Substitute the value of x here. X is negative 1, so 2 into minus 1 the whole square minus 3 into minus 1, here it is minus 1, plus 5. Simplify, you will get another value. 2 plus 3 plus 5, which is equal to 10. Here we can see when x is equal to 3, f of x is equal to 14. When x is equal to minus 1, f of x is equal to 10. Okay. Now we can consider another polynomial. That polynomial in y. Let it be g of y, another name. Here f of x, another name, we can give another name, that is g of y. Consider one polynomial as y cube minus 2y square plus 1. Okay. Now we can see when the value of y changes, what will happen? When y is equal to 2, g of y can be written as g of 2. Okay. Now write 2 cube, y is 2. Here 2 cube minus 2 into 2 square plus 1. When simplify, you will get g of y is 1. Similarly, when y is equal to 1, you can find the value of g of y. Okay. Now, our aim is we are going to study about remainder theorem. Okay, remainder theorem and factor theorem. Now, consider one example. Find the remainder obtained when dividing the polynomial 2x square minus 3x plus 5 by x minus 2. Okay, there is a question. Now we can write f of x, give the name. Let it be f of x. f of x is equal to 2x square minus 3x plus 5 divided by x minus 2. This is the dividend, this is divisor. Now, by long division, we can divide. Look here. By long division, look here. 2x square minus 3x plus 5 divided by x minus 2. Do you remember the process of division? Now, first term of the here, okay, quotient. First you have to find the first term of the quotient. How can you find the first term of the quotient? First term of the dividend divided by first term of the divisor, you will get this. So 2x square by x is 2x. So we can write 2x here. Now multiply 2x into x minus 2. Then write the answer here. Okay. 2x into x, 2x square. 2x into minus 2, minus 4x. Then subtract this from this as usual, like numbers. You have to remember the rule of subtraction. Change the sign of the number to be subtracted, then add. That is the rule. Okay, now we can change the sign as minus. Here it becomes plus. Now add these two. Minus 3x plus 4x, that is x. Here these two cancelled, it becomes 0. Now bring down the next term, that is 5. So we get x plus 5. Again the same process. X divided by x, that is 1. So next term of the quotient is plus 1. Write that term here. Now multiply 1 into x, x, and 1 into minus 2, minus 2. Again subtract this from this. Again write the rule, change the sign of the number to be subtracted, then add. So 5 again minus and this becomes plus. Add these two, you will get here 7. So we can see when this polynomial is divided by x minus 2, remainder is 7. Okay, remainder is 7. Now consider, you have to find the value of this polynomial when x is equal to 2. When x is equal to 2. Okay, you just look here. That is f of 2. f of 2 is equal to 2 into, instead of x square, 2 square minus 3 into 2 plus 5. When you simplify, you will get here 8 minus 6 plus 5. Apply Bodmer's rule. 8 plus 5 minus 6, that is again 7. Okay. Now, look here. We can consider another example also. Okay. Here we get that 2 like this. Substitute x minus 2 is equal to 0. Transpose 2 to the other side, we get x is equal to 2. Okay. So, you can see the remainder here 7. At the same time, if we find out f of 2, we get the same remainder. And we can see one more example. That is, find the remainder when dividing this polynomial, another polynomial, 2x cube plus x square minus 2x minus 1 by x minus 1. By long division, we can see the remainder. You can see by long division, look, 2x cube plus x square minus 2x plus minus 1 divided by x minus 1. The same process we can use. This long division you already studied, so you can do that. So here 2x square into x, 2x cube minus 2x square into minus 1 minus 2x square. You can see all these steps. And when you divide this polynomial by this x minus 1, we get the remainder 0. And in another way, divided by x minus 1. So, let x minus 1 is equal to 0, x is equal to 1. Now find what is f of 1. F of 1 is equal to 2 into 1 cube plus 1 square minus 2 into 1 minus 1. Find f of 1. You can see when we simplify, we get it's also 0. From these two examples, we can see no need of this long division for getting remainder when a polynomial is divided by another polynomial. Okay, another expression. Okay, so you just do like this. F of 2, you just find here in this case, if you find f of 2, that is the remainder. In this case, you have to find f of 1, that is the remainder. This is what remainder theorem. We can generalize the remainder theorem. Here you can see some more examples. When fx is divided by x minus 2, remainder is f of 2. Right? Now, when fx is divided by x minus 1, remainder is f of 1. Another one, if fx is divided by x plus 3, what is the remainder? Remainder is f of minus 3. That is, let x plus 3 is equal to 0. X is equal to transpose 3 to the right side. We get x is equal to minus 3. Therefore, remainder is f of minus 3. Here, remainder is f of minus 3. And in the next example, g of y is divided by y minus 5. What is the remainder? Remainder is g of 5. So we can generalize. Therefore, if a polynomial fx is divided by x minus a, general term, if a polynomial fx is divided by x minus a, the remainder is f of a. That is known as remainder theorem. Now we can see what is factor theorem. These two things are connected. Suppose 20 is divided by 4, we get the remainder 0. Therefore, we can say that this 5 is a factor of 20. At the same time, 4 is also a factor of 20. Okay, here suppose we are dividing 20 by 6. We know 20 by 6, we get a remainder 6. Therefore, 6 is not a factor of 20. At the same time, 3 is not a factor of 20. But here 4 is a factor of 20. In the previous example, when this expression, that is 2x cube plus x square minus 2x minus 1 is divided by x minus 1, we get the remainder 0. In this case, we can say that x minus 1 as well as this 2x square plus 3x minus 1 are the factors of this expression, that is fx. Okay. So, in this case, in the second case, x minus 1 is a factor of fx. Why? Because the remainder is 0. So, we can say if the remainder is 0, we can write this divisor is a factor of dividend. Therefore, we can generalize factor theorem. When a polynomial fx is divided by x minus a, this is what? Divisor. The remainder is f of a. That we know. That is the remainder theorem. Okay. And if f of a is equal to 0, that means if remainder is 0, we can say that x minus a is a factor of fx. That is what? Factor theorem. I'll repeat. When a polynomial fx is divided by x minus a, the remainder is f of a. And if f of a is equal to 0, x minus a is a factor of fx. Now we can see one example. Let fx is equal to x square minus 5x plus 6, which is divided by x minus 3. We know remainder is f of 3. It's very clear. X minus 3 equal to 0. Transpose minus 3 to the other side. We get x is equal to 3. Therefore, remainder is f of 3. Now, you can see what is f of 3. F of 3 is equal to, substitute 3 here. We get 3 square minus 5 into 3 plus 6. When you simplify, you will get 9 minus 15 plus 6. What is 9 minus 15 plus 6? Apply Bodmer's rule. 9 plus 6 is 15. 15 minus 15 is 0. Therefore, we get f of 3 is equal to 0. That means remainder is 0. Therefore, we can say that x minus 3 is a factor of this fx. Clear? Now, we are going to do some questions with the help of remainder and factor theorem. See, first question, exercise 8a, first question. Find the remainder when x raised to 4 minus 3x square plus 2x plus 1 is divided by x minus 1. First we can write, since x minus 1 is equal to 0, x is equal to 1. By remainder, so consider this the given expression. Let it be fx. We can write f of x is equal to the given expression. Now, we know remainder is, by remainder theorem, we can say that remainder is when this expression is divided by x minus 1, remainder is f of 1. So, instead of x, you can substitute 1, you will get the remainder. So, you can see the steps. F of 1 is equal to 1 raised to 4 minus 3 into 1 square plus 2 into 1 plus 1. When you simplify, you will get remainder is 1. So, when this expression is divided by x minus 1, the remainder is 1. Okay. Second question homework. Now we can do third one. See. Find the remainder when x raised to 4 plus 1 is divided by x plus 1. First we can write let x plus 1 is equal to 0, which implies x is equal to minus 1. So, when this expression is divided by x plus 1, remainder is f of minus 1, right? So, we can find what is f of minus 1. Okay? You can find it by yourself. Now, second part or second question. First subdivision. Show that x minus 2 is a factor of, show that x minus 2 is a factor of 5x square plus 15x minus 50. X minus 2 is a factor. How can we show x minus 2 is a factor? If f of 2 is equal to 0, we can say that x minus 2 is a factor of this expression. So, let consider fx is equal to this, the given expression. Then we can find what is f of 2. Find f of 2. F of 2 is equal to 5 into 2 square plus 15 into 2 minus 50. When you simplify, you will get 20. This term becomes 20. 15 into 2, 30 minus 50. Therefore, when we simplify, it's 0. Therefore, we know the remainder is 0. F of 2 is the remainder. That remainder is 0. Therefore, we can say that x minus 2 is a factor of the given expression. Okay. So, write the answer like this. Since f of 2 is equal to 0, x minus 2 is a factor of 5x square plus 15x minus 50. Okay. Now, second subdivision. Show that, same type of question, 3x plus 2 is a factor of 3x square minus x minus 2. Same pattern. Now, we can write since 3x plus 2 is equal to 0, transpose 2 to the other side, 3x is equal to minus 2. Therefore, what is x? X is equal to minus 2 by 3. Now, we can start. Let fx is equal to this, 3x square minus x minus 2. We can find what is f of minus 2 by 3. That is the remainder. We know the remainder is f of minus 2 by 3. Substitute minus 2 by 3 in the place of x and simplify. You can see this step and simplify this. When you simplify, you will get the answer 0. Therefore, we can write since f of minus 2 by 3 is equal to 0, that means since the remainder is 0, we can write 3x plus 2 is a factor of fx. Now question number 4. If 2x plus 1 is a factor of this expression, find the value of a. In this question, it is already given 2x plus 1 is a factor of this expression. So, what can we write? Remainder is 0. When this expression is divided by 2x plus 1, the remainder is 0. Because this is a factor of this expression, right? Therefore, we can start. Let fx is equal to 2x square plus ax minus 3. We don't know what is this constant. It is a constant. Therefore, 2x plus 1 is equal to 2. Since 2x plus 1 is equal to 0, 2x is equal to minus 1, x is equal to minus 1 by 2. Since 2x plus 1 is a factor of fx, f of minus 1 by 2 is equal to 0. Now we can see what is f of minus 1 by 2. Substitute minus 1 by 2 in the place of x here. 2 into minus 1 by 2 the whole square plus a into minus 1 by 2 minus 3. When you simplify, you can see, no, it is already given which is equal to 0. That is given because this is a factor of this expression. So, remainder is 0 which is equal to 0. So, simplify, we can equate this with 0. Therefore, consider this 2 into 1 by 4, that is minus 1 by 2 into minus 1 by 2, 1 by 4. Here minus of plus becomes minus a by 2 minus 3 which is equal to 0. So simplify this. 2 and 4 cancelled. Here we get 1 by 2. And here this is, you can transpose this minus a by 2 to the right side. And 3, minus 3 here. So 1 by 2 minus 3 which is equal to a by 2. Simplify that. Take LCM and simplify. 1 minus 6 by 2 which is equal to a by 2. What is 1 minus 6? That is minus, we can cancel minus 5. Here we get minus 5. We can cancel these two 2's. So we get a is equal to minus 5. Fourth section, second part is homework. Now fifth one. Find the value of constants a and b when x minus 2 and x plus 3 both are the factors of this expression. So we can see here two factors. X minus 2 is a factor. At the same time, x plus 3 is another factor. That means when this expression is divided by x minus 2, remainder is 0. At the same time, this expression is divided by x plus 3, remainder is again 0, right? Therefore, let's start. Let fx is equal to x cube plus ax square plus bx minus 12. That is the first step. Okay. Now you can see, since x minus 2 is a factor, here it is very easy to get the value of x. X is equal to 2. F of 2 is equal to 0. That is first equation. When x plus 3 is a factor, f of minus 3. Here f of minus 3 is equal to 0. We get two equations. That means substitute 2 here, we get one equation. Substitute minus 3 here, we get another equation. So, first equation implies, that is f of 2 is 2 cube plus a into 2 square, you can see here, b into 2 minus 12 which is equal to 0. And f of minus 3, substitute minus 3 instead of x, you will get this expression which is also 0. Now when you simplify the first equation you will get, when you simplify the first equation you will get one equation in a and b. 4a plus 2b equal to 4. Again we can simplify it. You can take 2 outside and simplify. You will get 2a plus b is equal to 2. That is equation number 1. Now second equation, f of minus 3. When you simplify this, minus 3 the whole cube, and simplify. You can simplify by yourself. So simplify, you will get 9a minus 3b is equal to 39. You can see all steps. And we can take common factor outside. 3 is common here. 3a minus b is equal to 39. Transpose 3 to the other side, we get 3a minus b is equal to 39 by 3 which is 13. Now you can see two equations. One is here 2a plus b is equal to 2 and second is 3a minus b is equal to 13. We can write these two equations together. Now, what type of equation is it? We know it is simultaneous equations. You have already studied how to solve simultaneous equation. So, just solve it like this. Add these two equations together. You will get, you just add these two. 3a plus 2a, that is 5a. These two, when you add these two, you will cancel this. 13 plus 2, 15. Therefore, 5a is equal to 15 and therefore a is equal to 3. Substitute value of a in any of these two equations, you will get b. So, equation number 1 implies 2 into, instead of a, substitute 3. 2 into 3 plus b equal to 2, which is 6 plus b equal to 2. Therefore, b is equal to 2 minus 6, that is minus 4. Therefore, a is equal to 3 and b is equal to minus 4.